Okay, guys, what I'd like to do is walk you through a couple of problems that are like what's in your homework on the second part of the Fundamental Theorem of Calculus. You have all the skills already. You just need to realize that these problems are really starting to put together several ideas that we've learned this year. So I'm going to look at, and if you need to pause the video, do. I'm going to look at page 443. And I'm going to use the graph and the prompt on 56, but I'm going to make up my own questions for it. But if you will open your book, that'd be awesome. Okay, so what I want to do first is make sure you understand if f of x is equal to the definite integral from 1 to x of f of t dt, then I can find f prime of x by doing the derivative of the integral. Oh, I said derivative of integral. So this is a DOI problem. So remember, we can do f of high, high prime minus f of low, low prime. So it would be f of high, your high limit's x, times the derivative of that x, minus f of low, your lower limit's 1, times the derivative of that 1, which is 0, okay? So what happens is you just wind up with f of x. Now that's important for you to recognize, and that generally is the pattern that's going to happen. On any of these problems where they give you an integral, define something like this, always find f prime of x, okay, as a starting point. So we've got problem 1 done. Now, for problem 2, if I want you to write the equation of the tangent line, remember you need a point on the tangent line, and it says at x equals 2. So I need to say 2 comma something, and I need a slope. Now remember, I'm wanting the tangent line to the graph of f of x. So to find the y-coordinate, I need to do f of 2. Well, f of 2 is this integral right here from 1 to 2. Now, to do that, I'm going to look at my picture, and I'm going to look at the area under the graph that's given. So I notice when I look at that, I have, if you're looking at your book, a trapezoid. If I look from 1 to 2, where at x equals 1 and x equals 2, that's a distance of 1. 1 reaches up to 1 comma 4 right there, so that this length is 4. For 2, the graph reaches up to 2 comma 2 right there, so that side's 2. So the area of that trapezoid is the average of your bases, so 4 plus 2 over 2, times the height of the trapezoid, which is 1, okay? So that gives me 3. So my y-coordinate is 3. Now my slope is f prime of 2. Well, guys, remember, f prime of 2 is little f of 2. And little f of 2 can be found by simply looking at your graph. And on the graph, I see the point 2, 2 again. That was this point right here. So little f of 2 is 2. So now I have a point and a slope. I can go to point slope form. And then I'll let you finish that up, okay? Now, I want to look at the next problem, problem 3. So remember, we figured out that f prime of x equals f of x, and I'm going to need to use that on this next problem. So where does capital F of x have a local min? So capital F of x has a local min when the graph of f of x decreases, and then turns and increases. So this is me thinking, but this is not necessarily me formally writing it up. So if f of x decreases, then I know f prime of x must be negative first and then be positive second, because I know that the derivative positive means the original function increases. Now remember, we know that big F prime is little f. So I'm looking for where little f is negative and then where little f is positive. So if you'll look at your book, I see that little f of x's graph goes from negative to positive at x equals 7, because I see that at 7, 0, there's a root, and the graph is going from below the x-axis to above the x-axis. So capital F of x has a local min at x equals 7. All right, last but not least, problem number 4 is going to be similar, but just a little bit more to it. So where is big F concave up? Well, I know concavity is a double prime, the second derivative information. So big F of x is concave up. So here I am, I'm thinking it through. All right, when the second derivative is negative, okay? Now, wait a minute. So if f single prime is little f, then f double prime must be little f prime. So I'm trying to figure out when little f prime is negative. But remember, if this derivative is negative, then the function itself must be decreasing. So now I'll look at the picture in the book. Where do I see the picture in the book decreasing? On the interval from negative infinity all the way to x equals 5. That's the left-hand side of the V that's going down like that. And there are just a little bit of examples that will help you move through the second part of this weekend's homework, hopefully more easily.